how to graph an exponential equation. And we had told you that there's a particular expression, y equals a b to the x minus h plus k, that helps detail the exponential function things. Okay, so we talked about how a, if we recall, okay, tells if it's reflected or not. Alright, and what that means is if it goes this way or it goes that way, or if it's going this way, if it goes that way, okay? If A is positive, okay, if A is positive, is not reflected. If A is negative, it is reflected. Okay? So this is the positive, that's negative. Okay? So very similar with what we saw with the quadratics. Okay? It flips it. It also makes it skinnier or like a wider curve as well. Okay? Then we talk about B. Okay? And do you guys remember what the B function told us what it did? Let's say if B is greater than 1, do you remember what we said it was? If B is greater than 1, this value here, do you remember what we said? If it's growth or decay, right? So this is going to be growth. And if B then is between 0 and 1, then it's decay. Okay, so those are a couple of characteristics there. Then we had the H, and the H was the horizontal shift. Okay, and the H is on the exponent. Okay, so you might want to see it like that. And then the K is going to be the vertical shift. And it's also going to be your asymptote. Okay? And that's the line that your graph will approach but never cross. Okay? So that was kind of what we did the last class period. Okay? So we're going to walk through this example and then I'll have you guys start working on the homework. Okay? So if I look at this example here, B, what is A's value? 5. What is B's value? 0.25. Okay. What is H? It is 0. And then what is K? 5. Okay. So there's nothing being added or subtracted to the X, so therefore that is H is 0. Okay. If you don't see anything there for H and K, it's 0. It doesn't mean it doesn't exist, it just means it's 0. Okay. If you don't see a value in front of B, then A is 1. So you always have A, H, and K, okay? And the parent function, we'll just talk about the parent function real quick. The parent function is just B to the X, so Y equals B to the X. And then A will be 1, H is 0, and K is 0. So they exist, it's just those are the values of them, okay? Alright, so looking at this example here, is this a growth or decay graph? It is decay because B is 0.25 and that's less than 1. Okay? Is it reflected? So when I'm looking at reflected, I'm looking at my A value. It is not because A is positive. A is a positive, therefore no. Okay? Alright, what's my asymptote? Y equals, it's going to be K, so what's my K value? 5, so Y equals 5. Okay, so that means up here, 1, 2, 3, 4, 5, this is where the line is going to be that the graph will approach, but never cross. Okay, so that's going to be that right there. Alright, so then my y-intercept, okay, is going to be when x is 0. When x is 0, what is y? Okay, so if we do this, we would do 5 times 0.25 to the 0 plus 5. Okay, well what's 0.25 to the 0 power? Anything to the 0 power is 1. Excellent. Okay, so that's going to be 1. So it's 5 times 1 plus 5. So that's 5 plus 5. So then what is the y-intercept? 10. So 0, comma 10. The y-intercept? The y-intercept is when it crosses the y-axis here. So the value of x is 0. A in the standard form, in like this is without the H and K, when H and K are 0. Okay? So if there's any H or K, then it's not A. Okay? Alright, so then we want to do points. I'm just going to spread it out because it's kind of a bigger equation. And then that's going to be 5 times 0.25x plus 5. Okay, so let's give it values of, let's just do -2, no, let's just do -1. -1, 0, 1. So if I put -1 in here, that's going to be 5 times 0.25 to the -1 plus 5. Okay? When you multiply that out, you're actually going to get a value of 25. So I hope you guys, if you haven't done this already in your calculator, you want to get comfortable with actually plugging in roots. So I would do like 0.25, and then I'm going to raise it to the -1, and then I would get 4. I would take 4 and times it by 5, and then I would add 5. Okay? So what you want to do is you want to do the exponent part first. You multiply it by A, and then you're going to add B. That's -1. I was going to do -2, but I was going to take it way off the board, so I just said -1. Okay? So does everyone get the order of operations on that? Because that's really important. Okay? So if I do 5 to the 0, it's going to be 5 times 0.25 to the 0 plus 5. Well, that becomes 1, so it's 5 plus 5 is 10. And then if I do 1 here, I would have 0.25 to the 1, which is going to be just 0.25 times 5. So that's, if you do 0.25 times 5, you get 1.25, and you add then 5, and you're going to get 6.25. Okay? So we have enough points here to go just kind of plot it out. So I'll do -1, 25, which is way off the board here. I have 0 to 10, so that's going to be 0, 1, 2, 5, 6, 7, 8, 9, 10. Be right there. And then I have 1, 6.25, so it's going to be 1, 6.25, which is about right there. So you figure it's going to come down to like this and just approach like that and then go up. Okay? So you guys comfortable with how I plugged in points to get my answers? And then I take those points. Again, this is the x value, that's the y value, so it's -125, that's 0, 10, that's 1, 6.25. Okay? And you kind of connect them, it's going to be like this curved L. Okay? What's my domain again that we said? What are the x values I can have here? All real. Or you can do that. And then what's my range? What are y values that I can have with all the x values I have? Yep, y is greater than 5. It's always going to be y compared to k. Alright? If a is positive, it's going to be greater than. If a is negative, it would be less than. Because negative flips it down. Right? And if a is positive, it's flipped up. What's that? Yeah. If a is positive, then it's going to be a y is greater than k. If a is negative, it's going to be a y is less than k. Because the a reflects it down, so your line would be down here, and so it's going to be that value less. Does that make sense? Okay? So that's kind of what we did then last class period. Okay? So, any questions on what we did?
So in the homework it says find the end behavior, and we marked it out on this one. Are we ever going to...
Alright, hold on a sec. Alright, so what we have here, you guys, we're going to be, we're working again on exponential functions. And today we're going to start talking about some of the properties of exponents that we've done before, and now solving for exponents. Because before, we've always solved for a variable being the base, you know, the x squared, and we had to solve for x. Now, our variable is that exponent, and so we're going to see how we can actually find the exponent part of it. Okay? So So just kind of remembering what our function was, the y equals a b to the x is like the simple form. We talked about how the b, if it's greater than 1, the function represents what? You guys remember? If b is greater than 1? Growth, right? And then if it's between 0 and 1, it represents decay. Okay? Alright, so we have some examples here that we're just kind of going to remind ourselves how that all works here. So if I look at this function right here, is this a growth or is it a decay? It is growth, okay, because your b value is 2 and that is greater than 1, okay? When we try to find our y-intercept again, that's where it crosses the y-axis, we want to set x equal to 0. So what is, because here it wants to know the y-intercept, what is the y-intercept here? So when x is 0, what is y? And that's the y-intercept. Okay, so how would I do that? I would say y equals 3 times 2 to the 0 power. So 2 to the 0 power is 1, right? Anything to the 0 power is 1, okay? So this will evaluate to 1. So that just becomes 3 times 1, so your y-intercept is 3. Okay, so when x is 0, alright, then y is 3. Okay, so looking at example number B, alright, so what is my B value here? It's 0.5, so is this growth or decay? It is decay. Alright, and then what is my y-intercept? So it's going to be 2 because when x is 0, so 2, I'll do 0.5 to the 0 power. So y equals, this again, the 0.5 to the 0 power is 1, so that just equals 2. Okay? Does that make sense? Alright, looking at C, what is my B value? It's 3/4. Is that greater than 1 or less than 1? It's less than 1, so therefore it's decay. Alright, and then when x is 0, what is y? It's going to be 1/2 times 3/4 to the negative 0. That just is going to be 1, so y equals 1/2. Okay, so are you guys comfortable with finding the y-intercept? You set the x equal to 0, and then you solve for the equation. Right? Okay, so that's good. So that's kind of reviewish. Alright, at this point we have some examples of word problems which we're not going to do, so we're going to flip. Okay, we're going to go down to example 3. Okay, in this example down here we're going to be working with how some of the rules with exponents, okay? So that we're going to apply this then at the next step. So just kind of reminding ourselves, if we have, here they're having it where we have radical expressions. So if you notice we have a square root of 5, or square root of 5 and square root of 3 are our exponents. We have over here square root of 2 times this, raised to the square root of 3, okay? So the rules when we're working with this is when you have two, and remember b to the x we talked about in the very beginning, this is what we call the base, okay? So the item that's being raised to the exponent is what we call the base. And for us to do anything with exponents, our bases need to be the same, okay? So if I have my bases the same, I can then just work with my exponents on top, right? So my base here is 2, my base here is 2. So my bases are the same, correct? Alright, so now if I'm multiplying two items together with the same base, what's the rule of exponents when I'm multiplying? I'm going to add them, right? So when multiplying, if my bases are the same, I can just add my exponents. So I would just write this as 2 square root of 5 plus square root of 3. Okay? So this right here is the same expression as that. If I wanted to calculate those out and merge them, I could. I can't, this does not become the square root of 8. Okay? This is still just a square root of 5 plus a square root of 3. If I had it where it was 2 square roots of 4, let's do 5. 2 square roots of 5 times 2, 3 square roots of 5. Let's say that was the evaluation. Okay? I would then say 2, and now when I add them together, it's going to be 1 square root of 5 plus 3 square roots of 5. Since the square roots of 5 are the same, they become 4 square roots of 5. Okay, so if the radical expression, the radicands are the same, you can merge them. If not, then you just have to leave them separate. So hopefully that's a reminder of what we did before. Okay, does that make sense? Mm-hmm. All right, so now looking at B, it's a little bit different of a problem. Here I have 7 square roots of 2 and it's being raised to 3, okay? So this is different, okay? This is being raised, it's to the power. So what's the rule of exponents when you raise something to the power? You multiply. So this one then evaluates to 7 square roots of 2 times square roots of 3. Okay? At this point then I can then rewrite this as 7 square roots of 2 times 3, which then becomes what? 7 square roots of 6. Okay? So we're going to be using these type of concepts, and so we just kind of remind ourselves how that all works. So hopefully that's a review for everybody. Is there anything else on that you guys want me to go over anymore?
No, I just have one question.
Mm-hmm.
Will we ever get a problem where the bases are not
Yes,
the same?
we're going to work on that next.
Okay.
Yeah. Okay. All right, so now let's move on to how we actually would work with this. So basically, we're going to be working with what we call the properties of equality. So basically, we want to be solving for exponents. And when you set it up a certain way, you can actually solve for our exponents. So here's an example we have here. If I have 2 to the x power, and I tell you that equals 2 to the 8th, what does x equal in this situation? Yeah, it's going to equal 8, right? So if 2 to the something equals 2 to the 8th, we know that x equals 8. Right? That would make that equation equal. Correct? Mm-hmm. So what that is telling me then is if I have a common base, okay, so if I have a common base, I can drop the base and set the exponents equal to each other. Okay? So notice how I could just drop this and it becomes x equals 8. Right? If I have the same base, it's like they don't exist, and then I can just work with my exponents. Does that make sense? Okay? So what's going to happen, though, is they're going to give you something and they're not going to be the same base. So the key is going to be trying to find the base that works for both, and then you can just work with your exponents and solve that way. Okay? So let's look at example number 4. If I example number 4, I have, I'm going to write it down here, 3, 2 to the x plus 1, and that equals 81. Okay? And I'm going to tell you, okay, I want you to solve for x. Well, you're going to be like, I don't know, it's in the exponent. How do I do that? Well, if I could get these two numbers to be the same base, then whatever is up on the exponents, I can just set equal to each other and solve. Okay? So this is where this lovely little chart comes in that I put out for you guys. What do I do with it? Should I borrow yours real quick? Alright. So if you don't have one, you guys just share your neighbors and then we can get more copied. So if you notice, I have a 3 and I have an 8, and I need to find a number that could be the same base. So I'm going to look to I'm going to start here in the first column with the smallest number that I have, and then I'm just going to go across and see if this number right here is in that row. So if I go to 3, I'm just going to go over and see if I ever find an 81, and I do. Okay? So if I find an 81, it tells me that 3 is a base for both of these numbers. Here it's 3 to the 1 power, here it's 3 to the what power? Fourth. Okay? So when I find that number, I can say, oh, I can rewrite 81 as 3 to the 4th. Okay? And then that makes them the same base. Does that make sense? So I can rewrite this 81 as 3 to the 4th power. Okay? So I can rewrite that. So the number is exactly the same, isn't it? And that still equals the 3 2x plus 1. Okay? So now that my bases are the same, it's like they can drop off, and I just set the exponents equal to themselves. So I would say, okay, I can do 2x plus 1, and that's going to equal 4. So the fact that the bases are the same, it's like they're not even there, and now I just take this, and I set it equal to this. Those are my exponents. Does everyone see how I did that? Alright, so now I have an equation I can solve, can't I? So now I just want to solve for x. So at this point, what would I do? Oh, let's go up here. I have 2x plus 1 equals 4. I want to do something before I divide by 2. Subtract 1, so minus 1, minus 1. So I get 2x equals 3. And I divide by 2, so x equals 3 halves. Okay? So if x equals 3 halves, these two sides will equal the same. Well, let's check that. Let's see. Let's do our check. So if I take 3, and I do 2 and multiply by 3 halves, plus 1, does that equal 81? Well, let's see. These 2's will cancel, so I have 3 to the 3 plus 1, which is really 3 to the 4th. Does that equal 81? Yep, 3 to the 4th equals 81. So that checks. Okay, does that make sense?
Yes.
No. Okay, so I put in 3 halves. It's kind of hard to read. I put in 3 halves for x, because my equation is 3 to 2x plus 1, right? So I put 3 halves in for x. Plus 1. This is 3. So my equation is 3 to the 2x plus 1 equals 81. So for x, I plugged in 3 halves. So this would be like 6 divided by 2, which is 3. And then I add 1, so that's 4. So the left-hand side becomes 3 to the 4th power, and that equals 81. Okay? Does that make sense? Alright, so questions on what I just did there. Alright, let's look at example number 5. So in example number 5, okay, I want to start with the smallest number that I have and see if I can make a base out of 4. Okay, so I'm going to go to 4, and I'm going to go across and see if I see 8 anywhere. Do I see 8 anywhere? No, so I cannot use 4 as my base. So what might be another number that would be common to 4 and 8? 2. So let's do that. Let's go to 2. On the line of 2, do I see a 4 and a 8? I do. So therefore 2 is going to be a base for 4, and 2 can be a base for 8. Does that make sense what I'm saying? Okay? So therefore 2 is going to be my base. So I can rewrite, I'm going to rewrite this a bigger. So I can rewrite 4, okay, so it's a rewrite, as 2, but what do I need to raise it to? Second. So I'm going to write 4 as 2 to the 2nd power. Okay? And then I'm going to rewrite 8. Well, what would 8 be? It would be 2 to the 3rd power. So I'd rewrite 8 as 2 to the 3rd power. Okay? So this number, the 2 squared, equals 4, and 2 to the 3rd equals 8. Now they have the same base, correct?
Correct.
Excellent. So now, notice how 4 is raised to the 2x though, right? So I just can't lose that 2x. So that 2x has to come down and multiply by whatever exponent I'm raising my base to. Okay? And this x plus 1 needs to come down. I'm going to move this over a little bit. X minus 1, sorry. I'm just going to rewrite this over here so it's easier to see. Okay? So this x minus 1, it's together. That needs to come down, and this needs to get multiplied by it. Okay? So this expression right here, 2 raised to the 2nd power multiplied by 2x, is the same thing as 4 to the 2x. Okay? My 2 to the 3rd times the x minus 1 is the same thing as 8 to the x minus 1. Okay? I have not changed the expression. So I could simplify this to be 2 to the 4x, and that's going to equal 2. This is going to be 3x minus 3, because I have to distribute this then, right? So 3x minus 3. Okay, and that becomes that. Okay? So now I have the same base, don't I? Okay? So we want, the first part was find the same base. Okay? Now that I have the same base, okay, so when you find the same base, now I can just drop it. These can just go away because it's the same, and now I'm just going to work with the exponents. So you could drop the base and set the exponents equal to each other, and then solve. Okay, so I'm going to do the 4x equals 3x minus 3. Does that make sense? And now I just solve for x. So what would I do? Subtract 3x. And so I'm going to get x on this side, and that equals negative 3. So what that's telling me is I take negative 3 and I plug it into this equation, it would work. So you guys want to do the check? I probably would, just to verify you got it right. So 4 to the 2x.
Good morning, teachers and students. Please excuse this interruption.
Next year you will be. All right. So then I'm taking, so the expression is the 4, 2 to the x, so I did 4, 2, put in x there, and that equals 8 to the, where x is I put in negative 3 minus 1. Okay? So my check, plug in negative 3 for x. Okay? So now I have 4 to the negative 6 here, and I have 8 to the negative 4 there. Okay, and when you plug that into your calculator, okay, and then on the other side it's going to be 0.0002 on, so they will be the same. Good? Alright, so when we look at this example here, what is our goal? So now you have this, number one, you guys need to recognize that you're trying to solve for the exponent variable. Once you see that, you have to realize, oh, I need to find the same what? Base, okay? So, I have 4, 3x minus 1 is greater than 1 over 256. Oh my goodness, right? So, are they the same base? No, they're not. 4 and 256 are not the same. So, I need to find a base. So I'm going to look on my chart. I'm going to start with the smallest number that I have, and I'm going to find it and go across and see if I can find the other number. And what did you find? 4 to the 4, right? So there you go. So I can use 4 as my base. So I'm going to rewrite this as 4, 3x minus 1. Nope. Is greater than 1 over, now I'm just going to take the 256 and write it as the base, so 4 to the 4, right? Because 256 can be rewritten as 4 to the 4. That gives them the same base, right? Alright, I have something in the denominator though. I don't like having exponents in the denominator. So what is the rule when I have an exponent in the denominator? Correct. So to bring it up to the numerator, I just flip it and then change the sign. So this actually can be rewritten as 4, 3x minus 1 is greater than 4 to the negative 4. Okay? So now,
That literally just makes it like negative 256.
it does not make it negative 256. It makes it a, when you have anything to a negative exponent, it makes it a smaller number. So that's why it's 1 to over 256. Like remember you did 2 to the negative 2 and it made it like 0.25 or whatever, right? So at this point, I have the same base, don't I? So what do? Cancel them. And so now I just set them equal to each other. So now I have 3x minus 1 is greater than negative 4. So now, even though I have an inequality, I solve it the same as I would with any inequality. So the rules for solving for inequalities are the same. Right? So you solve it as equal. If you have to divide by a negative, then that's when you flip it. Other than that, it's the same thing. So I'll bring the 1 over, so I have 3x is greater than negative 3. Divide by 3, x is greater than negative 1. Okay? So what this is saying is I need to find an x value greater than negative 1 to make this a true statement. So I wouldn't test it with negative 1 at this point. I test it with a number greater than negative 1. So like 0, 1, 2, whatever. Does that make sense? So on your check, you pick a number where x is greater than negative 1. So let's just do 0. Okay, so at that point I'd say, excuse me, 4 to the 3 times 0 minus 1 is greater than 1 over 256. So that becomes just 4 to the negative 1. Is that greater than 1 over 256? Okay, so 4 to the negative 1 is 1/4. And that is greater than 1 over 256. So that holds true. Okay? So does that make sense in regards to getting the same base? The reason you can get rid of the same base, it allows you then to work with your exponents and solve for the exponents. Because that's what we're going to be doing now. We're going to be solving for the exponents. The only way to do that is to get your base to be the same. So you have to find the commonality. Start with the smallest number and see if it works on that line. If not, work your way smaller until you see both numbers on that line. Does that make sense? And then you're going to take, this is going to be your base, and you'd raise it to whatever power you need to raise it to. Okay? Sound good? All right.